All right, so this is the first part of your Chapter 3 lecture, Defining, Measuring, and Manipulating Variables. So we've talked a bit about variables in general, right? Independent and dependent variables, how we measure them. Well, especially when we're dealing with experimental methods, we want to make sure we're measuring and manipulating variables systematically and correctly. So think about some examples of things we measure in science, right? How do we measure height or temperature or weight? Well, we use instruments that give us the most accurate or exact measurements possible, right? A scale, a thermometer, a height chart, a ruler. Well, we wouldn't use a scale to take someone's temperature, right? You'd use a thermometer. You want to use the correct measurement tool to get an exact measurement, right? Well, we've talked about before how defining and measuring things in psychology is a little bit more tricky, right? It's harder to measure behaviors and emotions. This is because most of these things and most things in general that we measure in psychology are what we call constructs. So take a second and think about what a construct is. A construct is a psychological state or process that is hypothesized to exist, but it can't be directly observed. So, what are some examples of constructs that you can think of? One of the most obvious and easily thought of examples is stress. Well, we know stress exists, right? But how do we measure it? How would you measure stress? Well, it's pretty tricky. We don't have a stress thermometer that gives us a stress temperature or something like that. We have to use our reasoning to determine the best way to measure that construct. Now, how do psychologists more precisely define a concept? Well, when we want to define a construct more specifically, we want to have parameters or a definition in which we can refer to. And what do we call these definitions? We call them operational definitions. So, an operational definition is defining the variable in terms of the operations or procedures that researchers use to measure or manipulate it. So, we operationalize every single variable in our study. And this goes back to our example of stress. So, based off of earlier examples like using a questionnaire or physiological characteristics, that's how we would operationalize that variable. So, there may be a well established stress questionnaire, or we may tap into someone's physiological response to stress, like how they sweat or their heart rate. Now, why are operational definitions so important? Well, think back to the big picture here. So, we have to be able to communicate exactly what we're doing in research, how we're defining it. That way, other researchers can replicate what we're doing. So, specifically, operational definitions can help us ensure that variables are being measured consistently. We can ensure that we are communicating our ideas to the community in a clear way. And this allows for replication and extension, which in turn better informs our theories that motivate psychological research. All right, so now we're going to talk a little bit about the four properties of measurement and what they are. So, first we have identity, then magnitude, equal unit size, and absolute zero. And we're going to go over each one of these in a little bit more detail. So first we have identity. And identity here simply means that objects that are different receive different scores. So the example here, we give one number to each category of different hair color, right? So blonde is 1, brunette is 2, red is 3, maybe black hair is 4. And we wouldn't code both blonde and brown hair as a 1 because they're different in their identity. We'd give them different numbers to differentiate between them. Now next we have magnitude. Magnitude refers to the order of the numbers reflecting the order of the levels of the variable, right? So think about favorites, right? So your favorite restaurant, favorite sports team, favorite TV shows. These would all have the property of magnitude, right? You'd give number 1 to your favorite, number 2 to your second favorite. The third property of measurement is equal unit size. So equal unit size means the difference between scores on the entire scale is consistent. So a difference of 1 means the same thing on the whole scale. Now grades is the example here. If you took the whole entire spectrum of grades you could receive in this class, a 0 for 100, the difference between a 69 and a 70 would be the exact same difference as an 89 to a 90, right? Now the fourth property of measurement is absolute zero, and it means just that. A 0 score reflects an absence of the variable being measured. So this is a good example is like the number of Spanish lessons you've completed. Most psychology majors had to take a foreign language, and Spanish is the most common taken among psychology students. So you can easily say 0 if you didn't take Spanish. Perhaps you took French or German or Russian, right? This can also be used to measure things like how many siblings do you have? Well, if you're an only child, 0. That reflects the absence of the variable being measured. Or how many times you've completed a 5K. Right? For me, that's 0. So these can equal 0, and 0 reflects an absence of these variables. So those are the 4 properties of measurement. Those are the 4 properties of measurement, and they're very important for several different reasons. So can you think of some reasons that it's important to know your data's property in terms of your research? Well, knowing the properties of our data informs us on several different things. It tells us which scale of measurement that we want to assume, which we'll talk about next, which statistics we can use to analyze our data. So you can't use different properties for different statistical techniques. There's some rules you have to adhere by for that. It can tell us how precise that we can be in our actually measuring and manipulating of variables. So we're fixing to discuss the 4 scales of measurement, and each of these scales has at least one of the properties that we just discussed, and some scales have all 4. The more properties that our measure has, the more precise that it is, but we'll get to more on that in just a minute. So your textbook discusses 4 scales of measurement, and they are nominal, ordinal, interval, and ratio. And we're going to talk about each one in detail. So for the nominal scales of measurement, numbers simply represent a category here and nothing else. So your marital status, for example, we could say 1 is single, 2 is married, 3 is divorced, 4 is separated. And we could do this for majors too. So 1 being a psychology major, 2 a philosophy major, 3 sports medicine, 4 biology, and so on and so on. Do you see how the number is simply representative of a category? 1 is not better or worse than 2. 4 is not better or worse than 3. They're just simply categories. So what properties does the nominal scale of measurement have? It simply has identity, right? It doesn't have magnitude, it doesn't have equal unit size, and it doesn't have absolute 0. It just has identity. Now the second scale of measurement is the ordinal scale. So ordinal scale is pretty straightforward. The values are rank order. The distances between the numbers don't have the same meaning, right? So let's look at our favorite movies as an example. But we could also do this with top scoring basketball players or best-selling groups, right? Just because these things are in order doesn't necessarily mean that there's equal unit size between the two. This scale of measurement only has 2 properties, identity and magnitude, right? So the numbers differentiate the identity between them, and magnitude lets us know that 1 is better than 2, which is better than 3, which is better than 4, but not necessarily in an equal fashion. So the ordinal scale of measurement is lacking equal unit size and absolute 0. Now the interval scale of measurement has equal distances between the values on the scale, meaning that they are measuring equal differences between the variables being measured. So the best example of this is a Likert scale, like on the pain measurement scale. Or maybe you've done a survey before that asked you to state how confident you are, or how much you agree or disagree with something using a Likert scale. While you can answer 0 on this scale, it doesn't intrinsically mean 0. So you can't make a ratio here, right? This might be a little confusing, but it'll make more sense after the next slide, trust me. So for the interval scale of measurement, we have 3 properties. So it has identity, they're different, magnitude, there's an order here, and equal unit size, right? So there's an equal distance between the answers on the scale. But it does lack an absolute 0, right? There's no absolute 0 value that allows us to make a ratio or a proportion out of these results. Which takes us to our 4th scale of measurement, the ratio scale. So the ratio scale of measurement is the most sophisticated scale of measurement. There is always an absolute 0, meaning that we can construct fractions and ratios from our data. Now, this doesn't matter at all to you yet, but it does mean that we can conduct more precise analyses on our data, right? So what properties does it have? Well, it has all 4. That's why it's the most sophisticated scale. And time is an example here, and age can also be used as an example. 0 means 0, right? And hopefully that'll make a little bit more sense as we continue to move on and discuss how these scales of measurement are applied in statistics. So we've learned what the 4 properties of measurement are and the 4 scales of measurement. Do you see how all of these things are actually building into measuring a single variable? Well, there's a couple things that we need to remember. So first, there's an implied hierarchy here. Each scale of measurement includes all of the qualities of the one below it plus one new thing. And the higher levels are more desirable because they're more precise. So the ratio is more precise than interval, which is more precise than ordinal, which is more precise than nominal. Now, one caveat, and this is very complicated to explain and slightly irrelevant to your understanding of scales of measurement, but just know that in some cases, many researchers do not distinguish between interval and ratio scales. So you may come across that one day in your research, but for the purposes of this class, we are going to continue to distinguish between the two. All right, so now we're going to do some simple practice with these just to kind of get you a little bit more familiar with the scales and properties of measurement. So have you ever taken a statistics course, right? What type of scale of measurement is this? Well, it's nominal. And what properties does it have? Identity. And that's it. For this one, what is your favorite amusement park? And you can select your top 3. See 1, 2, 3, and that kind of gives them some order here, which is a hint to the fact that this is an ordinal scale of measurement. And it has identity and magnitude properties. So this is an interval scale of measurement. You can see the Likert scale here is really kind of a dead giveaway. Anytime you see this, you're dealing with interval data. And this has identity, magnitude, and equal unit size. So this is the ratio. Remember, we talked about age here. How old are you? And this is the most sophisticated because it has identity, magnitude, equal unit size, and absolute 0. So let's review a little bit of what we've talked about in this lecture before we wrap up. So a construct is a psychological state or process that is hypothesized to exist, but it cannot be directly observed, like stress or depression. And our operational definitions include defining the variable in terms of the operations or procedures that the researcher uses to measure or manipulate it. And how are the two related? Well, the operational definition allows for the replication and extension of our work, which in turn better informs our theories that motivate psychological research on how we're defining, measuring, and manipulating those said constructs. And again, just to review, we have our 4 properties of measurement: identity, magnitude, equal unit size, and absolute zero. And finally, we have our 4 scales of measurement, right? Nominal, ordinal, interval, and ratio. I'm sorry I don't have those popped up on the screen for you. But if you need to, stop and review any of the things that we've discussed so far. You want to make sure that you're familiar with all of these things before you move on to the next lecture. As always, if you've got any questions, feel free to reach out to me via email, or we can even set up Zoom office hours if we need to go over any of these things in a little bit more detail.